Hi to all the students. Am I audible to each and everybody? Let me know. We have started the class 2 minutes ago because I was actually looking at the chat. Everybody was excited. Everybody is joining over here, and it was like even I just wanted to talk to you guys. So over here I am in front of you. Hi to Vidya. Hi to the genius Yuva. Hi Raghav, Abhirami, and we have Khushi, Satya, Lakshmi. Wow, so many smileys. I love this chat. I love you all. So thank you so much for joining much before I could start my class, and just because you guys were there in the chat 5 minutes ago, that's the only reason this class has been started 2 minutes ago. Okay, so let's do this. If you guys are going to be joining up this session 5 minutes ago, I'll be starting up this class 2 minutes ago every day. Okay, cool. Shall we have a deal over here, boys and girls? Let me know, each and everybody. And yes, share this session right now and let me know that have you shared it or not, because ultimately I am going to be taking up a few seconds, few minutes over here introducing myself and the Unacademy, the lovely platform, and over here I want the maximum number of students to join. My name is Luv Mehan. I am a graduate of IISc Bangalore. So yeah, if students gonna ask me, sir, are you an IITian? No. But is being an IIScian bad? Not at all. It's much more, it has much more proud feeling. And over here, I would like to tell you that you guys have to really join the Telegram channel where you will be able to see me is Luv Mehan JEE Chemistry. And apart from this, yes, you should follow me on Unacademy. Right now, I am having 2,000 followers over there, and one by one, drop by drop, just one by one, I am looking for, a bigger family. So do join that particular. Do follow me on Unacademy as well. And over here, do not forget to join the new Telegram channel, which is JEE English Unacademy, where we are posting all the daily sessions. So let it be physics or chemistry, and the PDFs as well. Everything has been uploaded over here. Do remember that. Daily check it out. Once in the morning, you'll get the PDFs, you'll get the alerts and everything. Okay. And now I would really like to tell you guys that if you guys had been following me on Unacademy platform, where you can anyhow search my name and search my profile, for 2021 students, there had been a crash course for advanced. For 2022 students, I had covered the 1/3 of the class 12th. I have covered the physical and almost the inorganic chemistry, I would say, from the from class 12th. And there had been a lot of courses which are running, which has started on the 18th and 11th of August, which are taught by the teachers who teach entirely in English. And you should remember that they had started their courses for 1 year and 2 year students. So I'm talking about 2022 and 2023 students. Yes, I am pretty much sure today, right now, as this is a periodic table class, most of the students would be 2023 students, but few 2022 students as well coming over here and revising up, right? So do let me know which all students are available in the chat. And over here, guys, do remember that whenever you are looking for extra tests, combats, scholarships, something big is coming up for 2022 students as well. So stay tuned. On this particular channel itself, you will be getting up the update, and for that, subscribe to this channel. And there had been a lot of batches, new batches, which are going to start this month. So on 1st of September, you again have the emerge batch, and you have 2022 batches. Dropper batches are also available. The last one is again the shine batch, which is going to help the droppers and the freshers, the 2022 students, boost their ranks. And apart from this, if anybody is looking for scholarships, then guys, always remember that ultimately Unacademy is always offering you 100% scholarship as well if you guys are going to get rank 1, 2 or 3. And this test happens absolutely free at every Sunday 11 AM, 1 hour test. And you should remember the enrollment is free. The code that you guys have to use is LoveGuru, your one and only favorite super code. That is going to be LoveGuru. Write this code in the chat so that you never forget this. And apart from this, 75%, 50 and 25% scholarships are also available. Isn't this amazing? And you should remember that whenever you guys are going to be, starting your preparation in on Plus and Iconic, you should remember on Unacademy, what do we really provide you? The best and the best teachers. You might be there, in any corner of this particular nation, but ultimately, if you are struggling to learn from the best faculty, from the best educators, then we have it. And apart from that, you guys get the live interactive classes where you can ask your doubts. Apart from this, notes and PDFs of the teachers are going to be available to you, and every course is structured, so you actually know when this particular course is going to get over. Apart from this, you should remember, you get live tests and quizzes which you might not be able to see on YouTube or any other platform. But now do remember, on Iconic you get personal coach and study planner, and I, for the 2022 students, recommend you guys to take minimum of 6 months of subscription and maximum of minimum of 18 months of subscription for 2023 and minimum of 6 months for 2022. And droppers as well, guys, pay attention. You should go for either 6 months or 12 months. For 2023 students, either 24 or 18 months of subscription. Wow, over here Genius Yuva has put the chat on fire. Okay, let's have everybody in the chat. So how many of you are active? I might not be asking you this again because I am pretty much sure you guys are serious ones and you would be making notes as well. So I might not try to ask you again, is everybody here clear, yes or no? Let's have everybody in the chat, whosoever is going to be there in the in the session till the end. Come on, let's have it. Raghav, it's okay. Till the session hasn't been started, I allow the spamming, okay, to happen. Amazing, amazing, amazing. Today's class is going to be more about arrangement. Now, I anyhow told you why do we need a classification, arrangement. What should be the pattern? Because anyhow we need all the things to be organized, and whenever we need to find some element, it should be easier for us. And if there is one element below another, then we should know that these are similar type of elements, just the way wardrobe has one pant over another, similar to that, right? But now we have already discussed what is the structure of the modern periodic table, and now we are going to talk about the trends. We are going to understand each and every block. So okay, so there are the colorful blocks, the S, the P, the D and F, and we are going to dive into it. Okay, I will be there. Amazing. So I can clearly see, yes, Khushi is over here. Bapre. Okay, I was just putting my phone on silent, and amazing. Go, okay, everything is over here. Now let's start the session. Over here, guys, the first and the foremost thing that you guys really need to understand is that Aufbau's rule, Aufbau's principle, Hund's rule and Pauli's exclusion principle has to be followed whenever we are trying to write the electronic configuration for any element. Okay, so we'll do it for that. Okay, so let's do it for very few elements so that I can clearly see if every one of you is having good amount of practice. Okay, so let's write it for hydrogen, 1s1, for helium, 1s2. So what rule are we talking about over here? So first and the foremost one is, that the Aufbau's rule is followed, where 1s having the least amount of energy is filled, half filled, and then the second electron comes, pairing happens, and this is Pauli's exclusion principle, right? So let's make these boxes as well, right? So do you see the Pauli's exclusion principle, where I'm making up two arrows opposite to each other? Now pay attention, guys. You also should write these things in your notebook. Okay, do not write it in the chat, but everybody should write in the notebook. And now pay attention, we'll do it for more. Okay, let's do it for at least 20. Now what is going to happen? 1s2, 2s1, then we have boron, 1s2, 2s2. This is beryllium, by the way, sorry. Then we have boron, then 1s2, 2s2, 2p1. Guys, let me know which group. I'll tell you that as well, because we are doing a recap and you guys love recap, right? Let me know in the chat, because I have been looking at this. A lot of students had been saying, sir, we really need recap from the previous class. So now group 1, group 2, Then over here again 2s1, group 1, group 2, right? Now pay attention, boys and girls, when we have p and s valence electrons, then ultimately group ns electrons, np electrons plus 10, group 13. Then again carbon 1s2, 2s2, 2p2, group 14. Then carbon, after carbon we have nitrogen, oxygen, fluorine, neon. Let's do it till here only, okay, for a practice. 1s2, 2s2, 2p3, group 15. Today we will talk about the names of these groups as well, the halogens, chalcogens and more, so stay tuned. And now over here let's talk about oxygen. 1s2, 2s2, 2p4, group 16. Fluorine 1s2, 2s2, 2p5, group 17. Neon, not nitrogen, 1s2, 2s2, 2p6, group 18. Correct? So we had been talking about the basic groups, and the ones which are really easier, the first ones which we see while putting up electrons. Then whenever we, after neon, there will be sodium, then we will be having magnesium, aluminium, silicon, phosphorus and so on. How many elements do you remember on your fingertips in the order? So just like when I was in class 11th, I'll tell you, I'll be honest, I only remember till the argon. Okay, I only remember till argon, and then later I remembered the D block elements. Okay, so it was I used to remember it on my fingertips, just like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and so on. So I made a kind, I initially in my initial days I used to just say it again and again. So now till date it's on my tongue. Okay, so do remember that. Come on guys, yes, mark your attendance, everybody. So didn't understand the S to the power and P to the power. Those are the number of electrons. Raghav, if you are missing these things, do remember that you have to actually watch some recordings, some of the atomic structure and the first class of periodic table. So these are the number of electrons. 1 electron in hydrogen, 2 electrons in helium, 3 electrons, and what's the point of 1s2 and 2s something? You have to follow the quantum numbers, you have to follow the last class of atomic structure as well. Okay, now ultimately, okay, so Aufbau's principle, what does it talks about? That lower energy orbital gets the electron first. I'm writing it in my own words, okay? And now when we talk about the Hund's rule, pairing happens only after the orbital, not the orbital, subshell being half filled. Again, atomic structure. We did this in the atomic structure chapter. And now the Pauli's exclusion principle. No two electrons should have same set of quantum numbers. Okay, do remember that. Cool. Is everything getting recapped? Let me know. And now over here, ta-da, whenever you see a periodic table, it's always colorful. And what does colors signify over here? You should always remember they can give any color. See, but also you should remember that any color that they provide, but they will always tell you what does red means. So all of these are alkali metals. Okay, then what about these yellowish orangish ones? Alkaline earth metals. Okay, Then we have metalloids as yellow: boron, silicon, germanium, arsenic, antimony, tellurium. Okay, and then ultimately transition metals, the D block elements. Correct. Post transition metals. Over here you have it. What does transition metals? We will talk about that as well later. So we have noble gases, the group 18s, we have the actinides, we have the lanthanides. Today we are going to talk about actinides and the lanthanides as well. These both series, these set of elements, the actinides and the lanthanides, okay, have been named after two elements, which are the actinium, and the elements later actinium are known as actinides, but all of these, not the actinium, later thorium and so on till lawrencium, this is F block elements. This belongs to F block elements. And when we talk about the the lanthanides, it has been named after the lanthanum. Do remember one thing, a lot of students do not know this. I'm gonna ask you this, okay? Is lanthanum and actinium, lanthanum and the actinium, do they both belong to F block or do they belong to D block? Let me know in the chat. Everybody, leave your pen and the notebook, type. I'm talking about LA and AC. Do they belong to F block or D block? Let's see, if you know this. Okay. Sir, what does group 13 signifies? So over here, when we talk about the group 13s, so over here what we really see is the boron, aluminium, gallium, indium, thallium is what you really have to remember till here. And ultimately you should remember the group 13 tells us that the elements over here which are there in group 13 will be having the electronic configuration which is ns2 np1. They have 3 valence electrons and their oxidation state can go up till 3, and a lot of things that we have to learn, but not now, in the chemical bonding chapter as well. Okay, so guys, do remember this. Okay, do write this down in your notebooks, because everybody is writing F block. You guys are wrong. You should remember lanthanum and the actinium. These are the D block elements which are placed here and here. Though lanthanum is a part of lanthanide series, the lanthanide series. Actinium is a part of actinide series, but these are not the F block elements. And we will talk about their electronic configuration as well. So now you should remember, because whenever we talk about the F block elements, they should have F electron, right? So whenever we talk about F, you should know 4F and 5F, okay? And ultimately, do remember one. We actually just talk, whenever we talk about, the F electrons, or the F block elements, there should be 14 in each period. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There should be 14. Do remember that. You can always remember like this. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? Because everybody knows this in my sessions, F subshell can only have 14 electrons. These two are not having 4F and 5F electrons. Do remember that. So what is the position of lanthanum and the actinium in the table? Group 3, group 3. Do remember that. And what is the position of all the lanthanides and the actinides in the particular periodic table? This is on you guys. Let me know. And I am going to teach you a lot of things that you might not be able to learn even by reading up a book or something. I mean, there are things, but the point is, if you are reading anything, with some less amount of care, then ultimately you might miss it. Okay? Okay, noted. Amazing. Then which elements are there in F block? The elements after LA and AC? Yes, genius you are. So you do remember that. Okay. Now, ultimately, we will talk about more. So do not worry about it. We will talk about more. And now, pay attention, boys and girls. We are going to do some questions, because anyhow I had been coming over here giving you a recap and letting you know a lot of things. Now this is your time to give me some answers, and then obviously we will start today's session as well. I mean, it's already started, still we are learning. Now over here the question talks about the electronic configuration of 2s2, okay, and 2p6. denotes to? Which of these elements? So ultimately you should always remember, whenever we talk about the noble gases belongs to group 18, and group 18, all the elements will be having the electronic configuration ns2 np6. Total 8 electrons are going to be the valence electrons in group 18. And now the correct answer to this question is absolutely neon. Okay, so neon is going to be the correct one. And who's the first one giving me this answer? That's genius Yuva. Then we have Khushi. And yes, come on guys, everybody has to participate. And now let's talk about the second question. Sodium belongs to which particular period? So let's write about the electronic configuration of sodium. So how is it going to be? 1s2, 2s2, 2p6, 3s1. Guys, do remember one thing. You should also remember the Z value of sodium. So Z, till neon, the Z value comes out to be 10. For sodium, it comes out to be 11. Right? The Z value comes out to be 11. And in neutral atom, the Z value is the number of protons and the number of electrons. Okay. Now, 2 to 4 and then 10 and then 11th electron. Now, according to 3s1, which period does sodium belongs to? Group 1, but period number 3. So, do remember that. Yes, ultimately, sir, where is 1s2? 1s2 for what? 1s2 is here, no? Tharshan, what happened? Is this clear? I made 1s2 over here. 1s2, 2s2, 2p6, 3s1. Okay? Okay. The correct answer to this question is going to be the third period. Amazing? Yes? And now let's talk about more. Let's, slightly increase the level of the questions. The element Z value 114 has been discovered recently. It will belong to which of the following family / group and electronic configuration? What do you really think? So guys, first and the foremost thing that you should see common in the in the option, Rn, 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 Rn. What is the Z value of Rn? Let me know. Guys, the Z value, the atomic number value for radon. Do you remember? How did I tell you to remember? Pay attention. Again, tricks: helium, neon, argon, krypton, xenon, and then radon. Pay attention. This is 2, then add 8, the magic number. Again add 8, 18, then again add 18, which becomes, you guys write it down, then add 18 again, and then add 32. So how is it going to be? 18 plus 18, ultimately it is going to be 36, then again add 18, 54, then add 32, 86. Yes or no? 86. Khushi, yes, absolutely correct. Sir, you could give DPPs. I am going to do that. But I am only going to give you DPPs only and only when you guys will be completing up a chapter with me. And atomic structures DPP is coming very soon. So stay tuned. And now guys, pay attention. Over here, what are we really talking about? We are talking about that the Z value of the radon is 86. What is the Z value of this particular element? So do this. So it is, we have to look for the difference of electrons. So over here, 114 minus 86. What is the number that you guys are going to get? Let me know. What is the number that you guys are going to get? Come on. Jaldi, jaldi, jaldi. The number that you guys really have to, tell me. This is the number of electrons that you really have to, put after radon. And at which particular period radon is available? Guys, pay attention. First period, second, third, fourth, fifth, sixth. This comes out to be at 6th. After radon, there would be a 7th period. Right? This 7th period means that the number of valence electrons are going to be in the 7th period. You will be able to see 7s and 7p. Correct? Now you really have to look for the number of electrons which are more than radon, and it comes out to be 28. Now let's see. The correct answer to this question is A. Pay attention. We have to look for number of electrons 28. 14, 10. How much? 24, 2 and 2. How much? Total 28. And when you are going to write 5f 14, 6d 10, filling up n minus 2 and n minus 1, f and d respectively, 7s2 and 7p2. When we talk about np2, just like 2p2, the carbon family, the group 14. So ultimately this is going to be the carbon family, group 14. Okay, and if you would follow the same steps, you will be able to solve this question within 20 seconds. Yes, I took 2 minutes, correct, to make you do that, giving you hints, reading up the question for you, showing you the path. Do remember that. Okay, yes, amazing. Now let's talk about another. An atom has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, till here helium, till here neon, till here we have argon, and then we have 3d3 and 4s2. You will place it in which particular period? So guys, let me know. I mean, which particular group? The group is the case. Yes, let me know. Let's see. Till here it's helium, till here it's neon, till here it's argon. So I'm gonna write it again. 3d3, 4s2. Now let us know, in which group are you guys going to add, put this element in. So ultimately, just do remember, first of all, just have the number of electrons in ns, which is 2, and then have the number of electrons available in n minus 1d. This is n minus 1, this is n, 4 is n, and this becomes n minus 1. The total number of electrons comes out to be 5. This is the number of the group that you should place this element inside. And the correct answer to this question, no, third nahi hoga. The correct answer to this question is 5th group. Vidya, do remember that. Which is going to be the element which will be there in the 3rd group? Guys, pay attention. Something like scandium, okay, which is going to have an electronic configuration as argon, 4s2. These 2 electrons will be filled, and these 2 electrons, this orbital will be filled, and then 3d1. Scandium is present at group 3rd. Do remember that. Okay? Yes? Don't be sorry. Give me a smile. Then only I'll feel that you are learning something. And everybody, if everybody is getting all these questions and how to solve them, give me a smile in the chat. And now let's move ahead. Over here, the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p3. What is the atomic number? Just add the number of electrons of the element which is just below the above element in the periodic table. So you do not have to add the number of electrons. See, I'll tell you something. I myself do not read the questions. I just simply bring it from here and there. I put it there. Okay. I have a good amount of question bank, which is on anyhow going to have good number of questions and good level of questions. So now you guys have to really tell me 1s2, 2s2, 2p6, 3s2, 3p3. And then ultimately what we are really talking about is an element which is present in 3rd period, but which is also present in nitrogen family. So nitrogen is present in 2nd period. What we are talking about over here is the phosphorus. And what stays below phosphorus? It's the arsenic. And just remember this. So whenever we have 2 plus 2 plus 6, so ultimately it becomes 10, and then we have 2 more, 12, and then we have 15, correct? Z value 15. What will you add to get an element below that? You just really have to add the 18 which Khushi is doing. Absolutely correct. The magic numbers. And the Z value is going to be 33. C is the correct answer. Amazing? Yes or no? Always remember magic numbers. Do remember that. 2, 8, 8, 18, 18, 32, 32. This one is only helpful in group 1. Rest you can use it in any group. So do remember that. Okay? Always remember that. 2 is only helpful when we are jumping from hydrogen to lithium. That's it. Rest, when we talk about, let's say, group 18, you go for this. Okay? Clear? Sir, is this a JEE main question? This is not a JEE main question, but this is exactly the level of the JEE main question. Exact. This can come. They can simply change the element or the electronic configuration. Do remember that. And now, let's talk about if the atomic number of the element is 33. It will be placed in which periodic? It will be placed in the periodic table in the which group? Let me know. So my doubt. Okay, I'll be taking up your doubt. Give me a second. By the time, guys, you should be doing up this question. I cannot see your doubt, Aditya. Give me your doubt again. Now, over here, whenever we're going to talk about the element number 33, again, how would you do that? 1s2, 2s2, 2p6, 3s2, 3p6. How many till here? 10 and 8. So this is what we are talking about, 18 till now. But now ultimately we have to put how many more electrons? Count it with me. So over here till here, as we are having 18, now what we are really going for is 4s2, 3d, how many? 33 is what we're talking about. If we go for 3d10, still it's 18, 20 and then 30. Let's go for 4p. 4p3. 4p3 means which particular group? Come on. Give me a second. Am I doing it wrong? Yes, because this has to be the 5th group. Give me a second. Okay. 33. The number of element. 1 second. 33. Something is wrong. Yes, something is wrong. Let it be. This shouldn't be the one. 5th group is not going to be the one. So do remember that. It has to be the 15th group. My bad. Yes, 15th group. Okay? Yes or no? Yes. And now, ultimately, let's move towards the next one. Now, the electronic configuration of 4 elements are given below. Which element does not belong to the same family as others? So look for it. How would you see whether it belongs to the same family? Ultimately, they should have similar electronic configuration. Okay? Nani Rakesh is saying, sir, hi sir, I wasted my 11th. What should I do? Please reply. If you have wasted your class 11th and if you are right on class 12th, do remember within 3 months, we are going to make sure that your whole class 11 syllabus is absolutely covered. So do remember, stick to the channel and watch it regularly. My chemistry classes happens every day at 9 p.m. Okay? And from today and from upcoming classes, what we are going to do we are going to make classes lengthier, but we will make maximum of 3-4 classes for each chapter so that we can cover up your syllabus really soon. So do remember that. Yes? Okay. Give me a second. Okay. Yes. Now let's move ahead. Sir, Mendeleev's periodic table, it is group 5. No. We are not talking about the Mendeleev's. Whenever the such type of question comes, we have to talk about the modern periodic table. So do remember that. Sir, will you be teaching for NEET? See, everything that I'm teaching right now over here is going to be helpful for JEE and NEET both. So do remember this. stick to the channel, and you do not have to worry about whether it is going to be helpful or not, because everything is going to be helpful even for NEET. Okay, now what is going to be the case, guys? Look for the similar electronic configuration: 4s2, 5s2, 4s2. Something is showing 3s2, but the last electrons are going in p. So which is going to be the correct one? Simple. C is going to be the correct one. Is this really clear to each and everybody? Yes or no? But also you should remember, whenever we're talking about, correct. Yes. So do remember that. But yes, you should also just remember that, whenever we're talking about 3s2, 3p5, 3D will come later, So do not get confused with whether in all the options 3D was available. So if we can look for just 3D not available, can we do that? Don't do that. Okay. Yes. And now let's talk about the S block. So guys, again, let me know what is the common electronic configuration, similar one, which is going to be NS1 till NS2. Okay. And when we talk about hydrogen, is hydrogen a S block element? Let me know. What should we talk about hydrogen? We are not going to count it in S block element. So do remember that. Whenever we're talking about it, yes, hydrogen is available in group 1, and it also talks about the 1s1 category, but whenever we study it, we are not studying it in S block even as a chapter. Okay, so do remember that. And now pay attention. So over here, when we talk about the S block, it is either having group 1 or group 2. So group 1 elements, whenever we talk about, these are going to have NS1 electronic configuration, and when we talk about group 2, then these are going to have NS2 electronic configurations. Okay, depending upon their period. So again, if lithium belongs to second period, it is 2s1. If we talk about beryllium, it is 2s2. If we talk about rubidium and strontium, 5s1. If we talk about strontium, 5s2. Okay, is this clear to each and everybody? Come on, let me know. And apart from this, these have some common names as well. So group 1 elements: lithium, sodium, potassium, rubidium, cesium. Do I use some mnemonics to learn these elements? The trend, the arrangement? No, I'm not the mnemonic guy. Okay, if mnemonic helps you, you can surely go for it. I'll give you the mnemonics as well. But to be very honest, even you can do it without mnemonics as well. So do remember that. Now, over here, whenever we talk about the alkaline earth metals, these are the beryllium, magnesium, calcium, strontium, barium. Again, no mnemonics. It's there in my mind. If you just do it by heart, you will always remember it. And now, let's talk about some of the features. Guys, do remember, let's talk about sodium, an example. Sodium as an example. What is the electronic configuration? This one comes out to be neon, 3s1. So ultimately, this is how it is. Now, just to show you, just to give you an example, this is shell number 1. How many electrons are going to be there in shell number 1? Only 2. 1s2. Okay. Crosses are electrons. Shell number 2, 2s2, 2p6. Total 8 electrons. Clear? Shell number 3. How many electrons in shell number 3? Only 1. If we can remove this one extra electron in the outermost shell, then ultimately what is going to happen? If we remove this electron, then the group 1 elements attain the noble gas configuration. So whenever we remove one electron from the noble, the alkali metals, and make it a cation, then ultimately they achieve the noble gas electronic configuration, which makes it stable, which makes the ion stable. And this is where, whenever we have to remove this electron, the metal, the atom, does not resist much. It resists, but not much. It happily gives this electron. So ultimately, whenever we have to snatch away the electron from the atom, it requires less energy. And why are we even providing energy? Because the outermost electron that we were talking about is still having some attraction with the protons, and in order to break this force between them, in order to overcome the force, this is nucleus, this is the electron, they are having too much love between each other. If we are going to remove this electron, we have to pull it, and this is where we have to provide the energy. So do remember this. So now over here, whenever we talk about the group 1 elements, they show +1 oxidation state or the charge on their ions. When we talk about group 2 elements, now pay attention guys, when we talk about magnesium, the electronic configuration comes out to be neon 3s2. Now what do you think, boys and girls? How many electrons does magnesium has to remove in order to become stable? Because anyhow, a fully filled shell is actually the most stable configuration. So how many electrons? It has to remove 2 electrons, which is absolutely correct. The answer given by Genius Yuva. So ultimately, the magnesium will show us a stable oxidation state of +2 or the charge. Okay, so do remember that. +2 is the oxidation state that magnesium or beryllium or calcium and so on will give us, the group 2 elements. And you should remember the electronic configurations, what I have told you, because of high reactivity, they are never found in pure state. Why is that? Why the reactivity is too much higher? Because they are, these group 1 elements and the group 2 elements are always ready to give their 1 or 2 electrons respectively to anybody else, because they are going to be happy as soon as they achieve the noble gas configuration. So in nature, they are always ready to provide their electron to the electronegative elements, just like chlorines, oxygen, or halogens, or carbonates, whatever. Okay, and now guys, pay attention. Except lithium and beryllium, guys, you can also guess why only these two show us anomalous behavior. Okay, the remaining elements of these groups form ionic compounds, but not the 16th and the 17th, not the 6th and the 7th, 16th and the 17th group elements. What's so different with lithium and beryllium? What do you think, guys? Think about this. Whenever we talk about lithium, the electronic configuration comes out to be 1s2 2s1. That means if this is nucleus, first shell, second shell. And when we talk about beryllium, 1s2 2s2. Electronic configuration of beryllium with magnesium, calcium, strontium, barium, all of these are having similar electronic configuration. What is different? It's the size. The size of the beryllium is so small that it does not easily give its own electron. The size of the beryllium and the lithium is so small. So guys, do remember this. When the electrons are far away from the nucleus, they can be easily removed out. Okay, if this is the third shell, but if there is an electron in the second shell, and if we are trying to remove this is going to be a tougher one. And it is tough for us or for any element to remove the 2s1 electron when compared to the 3s1 electron. So do remember that. When size becomes smaller, the pull from the nucleus is stronger. Okay, closer it is going to be to the, I always think about, which is a very different type of example. Let's say this is picnic, where every teacher is taking you to the, from school, or maybe these are your parents, and this is a small kid, and somebody else is trying to manipulate this kid, showing candy and trying to snatch it away. So if the kid is close to the students, close to these, not students but the parents, which one is easier to take the kid? Which case is easier where the kid can go away with a stranger? Let me know. It's the one where the kid is going to be much more far, correct? Where the kid is going to be much more closer to the parents, it's going to be tougher, correct? So always stay close to your parents, because anyhow, for me, you guys are 5 years old. Okay? So if you had to be a kid, if you want to go back, if you want to reduce your age, at what particular age would you like to go? Let me know. I would like to go in nursery class. I mean, when I was at age 4, that was a good time, playing with toys, colors. Even I used to have a cursive writing book, which I never used to fill it properly. Yeah, something like that. Okay, so now do remember that. Okay? When we talk about the lithium and the beryllium, you should always remember that because of their smaller sizes, they do not really give their electrons very easily. Okay? Okay. Because of school, there are a lot of pollution, due to transport. Okay? You guys are talking about something else. Smaller in size, more ionization energy required. Absolutely correct. The genius you are. I enjoy my current age. Even I do. But yeah, just for fun. Now, do remember that. Okay? I'll do it. This is group 17, group 16. Do remember that. Okay? Now, ultimately, we're talking about more about S block. You should remember the metallic character and the reactivity increases down the group. So, whenever we talk about lithium, sodium, potassium, rubidium, cesium, what's changing? Whenever we go down the group, atomic size increases. And why is that? Because earlier, when we talk about lithium, the outermost shell, that is the second shell, 2s1. Then we have 3s1. The electron is now in the third, the valence electron is now in the third shell, then in the fourth shell, then in the fifth shell, and then the sixth shell, right? So, when the shell is increasing, will the atomic radius increase? Will the atomic size increase? Yes. So, as we go down the group, as we are changing the number of periods, yes, the atomic size increases. And as the valence electron, this cross one, becomes far away, becomes too much far away from the nucleus, which one is easier to lose? Which one is easier to lose? The ones which is way much far. And hence, when the ionization energies for these electrons also decreases down the group. So guys, do write this down with me. I'm anyhow going to teach you what is ionization energy in the next class as well. Okay, ionization energy decreases, and then the reactivity increases. And when we talk about the reactivity of metals, yes, metallic character increases. Do remember these things. Okay, is this clear to each and everybody? Come on, everybody. Achha, a lot of you guys are actually talking to each other in the chat. Do not do that. Okay, pay attention over here. Now let's talk about something else. Now pay attention, boys and girls. Electropositivity increases down the group. What exactly happens? They are not the ones which are ready to snatch away the electrons. They are the ones which are ready to provide the electron, give their own electron, donate their own electron. So ultimately, this is a positive behavior towards electron. Negative means, the ones who just wants to snatch. But positive one means who just wants to donate, who just wants to, donate it. So then electropositivity increases. Electropositive character increases, or in other words, electronegative character decreases. These are the things that you should write in your notebook. Okay, and now guys, pay attention. We are diving to P block. Whenever we talk about P block, it starts from group 13, it ends at group 18, right? Group 13 is also known as the boron family. Do I use mnemonics to remember them? No. Okay, but people do it. They call it as Baggett, B-A-G-I-T. Okay, but I never did that. Boron, aluminium, gallium, indium, thallium. Okay, you do not have to remember the last ones. Okay, don't worry about them. You just have to remember the 5. What about the carbon? Carbon, silicon, germanium, tin, and lead. What about nitrogen? Nitrogen family is group 15. Nitrogen, phosphorus, then arsenic, antimony, bismuth. Oxygen. For oxygen family, you can even remember 4. No issues. Oxygen, sulfur, selenium, tellurium. That's it. And for fluorine, the halogens, fluorine, chlorine, bromine, iodine. Do not worry about the astatine. Don't worry about it, even 4. So what I am going to tell you is, do remember these 4 from group 17 and 16. This is what you really guys have to remember, okay, with the sequence. And now, what about the noble gases? You have to remember till radon. So how is it going to be? Helium, neon, argon, krypton, xenon, radon. Okay, don't worry about the OG. Okay, till radon is what you really have to remember. And the radioactive ones are really shown to you. So all the radioactive ones is what you do not have to remember. Okay, yes, give me a smile in the chat. And now guys, pay attention. All of these electrons, this, where are these electrons going? The ns, or this orbital is going to be filled np1 till np6. So np1, np2, np3, np4, np5 and np6. And as soon as np6 configuration has been achieved, the stability of the element is going to be the maximum, because noble gases are the inert ones only and only because their outermost shell is fulfilled. The np6, it's a very stable electronic configuration. So do remember that. Now over here, whenever we talk about few more things, what is really going to happen over here, you should remember in the p block we do have metals, non-metals and metalloids. So we have non-metals, metals and metalloids. But when we talk about the group 1 and the group 2, the S block, we only have metals. We're not talking about hydrogen. Hydrogen is a non-metal. Okay, now pay attention. And amphoteric metals as well, we will talk about those as well. And now we also, apart from non-metals, metals and metalloids, we also have the gases, the noble gases. So because you don't say that these noble gases, you should not categorize it somewhere else. Do remember the color combination is what you can see is at non-metals. Leave it. What you really should remember, that these are noble gases. And apart from this, the group 16 elements are known as chalcogens. A lot of times question is going to be there and students should know. The spelling is what I am writing it for you. Oxygen family. Okay, and when we talk about halogens, group 17, the fluorine family, do remember that. And now over here, this is what you are looking at, the p block. Okay, why not helium is counted in p block? Because you should remember the electronic configuration is what I wrote, np1 and np6, from np1 till np6, np1, np2, np3, 4, 5, 6. What about helium? Whenever we talk about helium, it has an electronic configuration of 1s2. It is not 1s2 1p6, correct? That's the only reason. Again, keep it aside, though it belongs to group 18, but according to the definition, according to the eligibility criteria, you got the answer, correct? And now ultimately let's talk about few more names. So just like you have guys a lot of less students and especially NEET students as well, not everybody would be knowing this, so you can challenge your friends as well. So anyhow, these two things, halogens, everybody knows. Group 17 is known as halogens. Group 16 elements, the chalcogens. Group 15 elements, the nitrogen family. Nictogens. P becomes silent over here, so it is going to be nictogens. Okay, P is going to be silent, nictogens. Okay. Carbon family elements are known as tetragens. Tetra, I mean, you can remember that they have 4 valence electrons, so that's the reason tetragen. Okay. And when we talk about group 13, the boron family, icosagen. I mean, I mean, even I do not know how to pronounce it well. Okay. Icosagens. Okay. Icosagens. There are some different pronunciations. Whichever you like, you can keep it. Is this really clear? Yes. So, but anyhow, do remember that there is no point of simply mugging up the electronic configurations. It's very much easy. Group 13, it should be NS2 and P1. 13, 3. Group 14, then we are going to have 2s2, 2p6. Group 15, 5, 2s2, 2p3. And then so on, you have to go. Okay, so do remember these things. So I didn't knew this. Well, now I know. Nice. Amazing. That's what I'm saying this. You know, challenge your friends. Which elements, which group are we talking about when we talk about tetragens or nictogens? Okay. And anyhow, these names could be there whenever we talk about the JEE. Okay. So do remember, boys and girls. And now let's talk about the D block. D block starts from, not this color, group 13 and ends at group 12. How many elements should be there in one period, in one series? It should be 10. Group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total 10 elements. Okay. And what is going to be the electronic configuration? Always remember, NS will be always filled. And when we talk about the D subshell, it will be N-1 D from 1 till 10. We'll talk about some exceptions, so-called exceptions, which are no more exceptions. Guys, pay attention. Achha, by the way, why did I write N-1 later and NS first? Because NS is filled first. Let's talk about it. 4S and 3D. What is the N plus L value according to Aufbauer's rule? We are doing the Aufbauer's rule over here. It's 4 plus 0. It's 4. When we talk about 3D, it's 3 plus 2. It's 5. Lower the N plus L value, the electron, gets into that particular orbital first. The subshell first, right? So do remember that. That's the reason I'm writing for NS first, then N minus D later. But do remember that when we talk about, let's say, 4s2 and 3d6, which are the outermost electrons? Let's see. Which one of these are the outermost electrons? 4s or 3d? Come on. It's going to be the 4s ones. Why? Higher the N number, which means we're talking about the another shell. 3D is belonging to third shell. 4s belongs to fourth shell. The valence electron is, the 4s2 electrons. Do remember that, okay? And now, pay attention, boys and girls. You should remember, whenever we talk about the D block elements, you will be able to see some electronic configurations like of chromium and copper, which is slightly different. And why is it different? Because over here, 4s2 is not available. It's 4s1. And why is that? What should be the electronic configuration? What we were expecting and what is really there, we will talk about. So let's talk about the expected ones. In the case of chromium, the Z value comes out to be 24. In the case of copper, it comes out to be 29. Yes, if you are thinking that should I be the one who should remember these atomic number values, then my answer is yes, you should. And now pay attention. When we talk about chromium and copper, the electronic configuration had to be like argon 3d4 4s2 and argon 3d9 the copper 3d9 and 4s 2. This is wrong. I'm telling you, this is what we were expecting. That's not the case. Why? Because this 4s2 is fully filled. This 4s2 is fully filled, correct? Now just because whenever a subshell or an orbital is fully filled, it's happy. Happy. Is 3d4 fully filled? Is 3d9 fully filled? It should be 3d10 and 3d10 or 3d5. What about half filled? Even half filled electronic configurations, half filled subshell makes the electronic configuration much more stable. So what is going to happen is I am going to rub a lot of things. From 4s2, put one electron back to 3d and make it 3d5. 4s1. 3d5 is a half-filled subshell. Is it happy? Is it stable? Yes. And when we talk about 4s1, again yes. When we talk about 3d9 and 4s2, bring one electron back, make it 10, okay, and make it 1. 3d10. Is 3d10 happy? Yes. What about 4s1? Half filled? Yes. So this is how the electronic configuration of chromium and copper does not show you 4s2 electrons. It has one electron each. The electronic configuration shows you 4s1 and 4s1. Rest, whenever we are going to talk about, I am going to give you the best trick any JEE or NEET student can have, and that's the whole damn reason you should remember the atomic numbers. Guys, stay tuned and challenge your friends. Now over here you should always remember, after calcium, calcium is having the atomic number 20. After that we start with scandium, and you should remember the series 1 of D block elements by your heart. So scandium, titanium, vanadium, chromium, then manganese, iron, cobalt, nickel. 8. We're talking about 28. Copper, cobalt. After nickel, cobalt, copper, and zinc. So now guys, do remember. So whenever you talk about 21, I'm telling you the trick to write the electronic configuration. Write 4s2, 3d1. We're talking about 21, right? 1 is going to be for 3d, 2 is going to be for 4s. Do it. Okay? Titanium, 4s2, 3d2. Vanadium, 4s2, 3d3. Chromium, I told you, no, it's not going to be 3d4 and 4s2. 3d5, 4s1. Okay, I'm writing up over there. 4s2, 3d5, 4s2, 3d6, 4s2, 3d7, 4s2, 3d8. Cool. Now over here, 4s2, 3d9 is not going to be the one. 3d10, 4s1. And then for the zinc, don't write 4s3, 3d0. Do not write that, okay? Do not write 4s3, 3d0. It's going to be 3d10, 4s2. Is it good? Come on. Will this trick make your things easier? That's the reason you should remember the atomic number from scandium till zinc. And it will always help you to write the correct electronic configuration. And I'm telling you something. This is known as series 1, series 2, series 3, series 4. Series 1 is the most frequently asked in JEE examination and NEET examination. And now guys, pay attention. See, lanthanum and actinium belongs to D block. Do remember that. This is F block. Cerium, from cerium and thorium, F block element starts. But does lanthanum belongs to lanthanides? Yes. Does actinium belongs to actinides? Yes. But these are not F block elements. Do remember that. Sir, I'm going to be smarty pants soon. Yes, obviously. In your own world, among your friends, you will become smarty pants when I am going to be taking up class regularly and you guys would be attending it regularly. Amazing. And by the way, if you really like this trick, come on, you really do have to hit the like button, okay? And now let's talk about few things. So over here, I am not going to discuss about why is it NS 1 to 2 and 3D 1 to 10. Stability of half filled and fully filled subshells. All of them are metals. All of them are metals, okay? Iron, nickel, cobalt, है ना? Chromium, titanium, tungsten, and you can go on and on. Mercury, gold, zinc, not aluminium, I'm so sorry. Silver and gold is what I was talking. Platinum, everything, okay? And now, mostly forms colored ions. So whenever we talk about they losing up electrons, these electrons losing up electrons, their ions will always provide colors to the medium, okay? And now whenever we talk about the oxidation states, we will talk about this later, okay? Whenever I am going to take you forward to this, in different chapters, I'll tell you about the oxidation states as well. And now they all show paramagnetic nature. That means they are attracted, they are weakly attracted by the, they are attracted by the magnetic field. So whenever there's a magnet, they will get attracted. They are used as catalysts as well. They are used as catalysts as well. Do remember that. So what is a catalyst? Whenever we put a catalyst for a particular reaction, ultimately a catalyst always reduces the time for the completion of reaction. So if a reaction has to take 10 minutes to complete, it will take 1 minute or maybe half a minute to complete. Okay, so do remember that. And now, sir, why are you not taking sessions on JEE Champions? Aditya, I have not been taking up because ultimately you do have teachers over there as well, and there had been a lot of students who really require quality, best education, in English, and not every teacher is capable of teaching students in both the languages, where I feel I am, and this is my sole duty to take care of each and every type of student. And this is where I believe if I am teaching students in English, a lot of students who have very less option on YouTube would feel good about it. Okay, now let's talk about few more. Whenever we talk about zinc, cadmium and mercury, guys, pay attention. These are very different three elements. I'm going to talk about them. To which particular group do they belong? I'm going back. They belong to group 12, zinc, cadmium and mercury. In the same group, group 12. Guys, pay attention. Whenever you see their electronic configuration, let's talk about zinc itself. It is 3d10 4s2. Correct? Do not show most of the properties of the transition elements. They show very different. They show a lot of different properties when we compare from others. Iron, manganese, nickel, cobalt and so many. Okay. And why is that? Because you should remember that ultimately, even if you actually remove the 2 electrons from here, there 3D, there's no unpaired electron. There is no unpaired electron available, even here, even here. So do remember that. Okay. Yes. And now their properties are between chemically active metals of S block, which are like sodium, magnesium, and less active elements of group 13 and 14. So they are in between. Okay? So do remember that. And now let's talk about these. All are known as the transition elements. Not these that we're talking about. We're talking about the D block elements. But you should remember one thing. There is a difference between the transition elements and there is a difference between the D and F block elements. Let me ask you one thing, and this is going to be a homework. The class is not over. Whenever I'm giving a homework, that doesn't mean the class is over. But you have to complete this homework and you have to let me know in the comment section. Okay? And now guys, let me know. Does zinc belongs to D block? Yes or no? This is one. And does zinc belongs to transition elements? Let me know in the in the comment section, not in the chat. This is going to be a homework. Okay? This is going to be a homework. And similarly, the same answer is going to be for cadmium and mercury as well. Yeah, no, I don't want that in the chat. Complete statements, and I'll give a thumbs up. I'll give a like to all of those who are going to complete this homework, okay? But it should be correct as well. And now we're talking about the F block elements. So whenever we talk about the F block elements, they all belong to group 3. They have not given any space in the main body of the periodic table, and everything is actually kept inside the the group 3. And now over here, guys, pay attention. This starts from the lanthanides, and lanthanides are available in period number 6. Period number 6 starts from which particular element? Cesium. So after cesium, and then after the cesium and barium, then we are going to have the lanthanum. Okay, so lanthanum is going to be there. This is group 3 where lanthanum starts, right? I mean, this is lanthanum where group 3 starts. What am I saying? And now pay attention. From cerium, F block starts. This is again group 3, and inside the group 3 we have thorium and all. And now over here, guys, do remember the Z value 58, and this is for cerium, okay, 58, and it goes till 71. 71. This is missing. Okay, let me just write this once more with the white. (71). Okay, and when we talk about the actinides, Z value 90 till Lr, lawrencium 103. So do remember that. Okay, something is missing with this particular diagram. Let's go back. Yes, Lu, Lr. Guys, are you able to see Lu and Lr? Lu, lutetium, Lr, lawrencium. I just feel like putting V over here, and that will become my name. Which particular element suits your name? I mean, which would be similar to your name, or where if you want to keep a symbol or a letter for your name, which letter would that be? Which element would that letter would become? So let me know. I think lutetium is the closest one to mine. I cannot talk about lithium or and there is no element as L as well. There's no see, if you would see, there's nothing, or maybe LV is there, but I think Lu is much better. What do you think? So Praveen says P, it's phosphorus. So write it P, phosphorus. Khushi can have K, potassium, right? The genius Yuva, what will you go for? Let me know. So do it with your name, not with your YouTube username. Chris, Krypton, amazing. Anybody else who would like to participate over here? Aditya, which one is going to be for you? Let me know. A, just A. Maybe you can go for not aluminium. Ag, silver. Okay, so now over here also let me know, ask you one thing. One quick question. Which all letters are missing in our periodic table? From A till Z, which all letters are missing in our periodic table? You guys have to let me know. The board is all yours. Which letters are missing in the periodic table? You never thought about it? Maybe your friends would be thinking about it, or if they are not, just ask them. Khushi says the letter J. Guys, can anybody spot letter J? It's missing. You cannot. By the way, Aditya, you can go for 80. Astatine. It's much better. But anyhow, there's one more letter. Yes, Aditya is right. It's Q. Q is also missing. Apart from that, everything is there. Z, zinc. X, we have xenon. Y, deuterium. We have every letter. just not the J and the Q. If you get a chance to discover any element, maybe you just be the one who is using J or Q to name that element. Okay, so do that. Whenever you go big, whenever you become scientist, you become you discover your own elements, then do that. Okay, but now let's go back, and ultimately, yeah, so this is the whole periodic table. I will be sending you the photograph in the Telegram channel as well, and so that you can revise. But now over here, whatever you should remember for about the F block elements, also known as inner transition elements. The transition elements, the D block elements, the inner means which are inside, which have been kept inside, behind, or inside the D block elements. So now ultimately all of these are again metals. All of these are again metals. A lot of them are radioactive. Thorium, uranium, and a lot of them are there. And now over here, yes, a lot of them are radioactive. The elements after uranium are called transuranium elements. Where is uranium? 92. After that, everything had been, everything is called transuranium elements. Sir, will I send my general doubts now or after? You can always send me your doubts in my Telegram channel. I'll always reply. Do remember that. Okay. And now we have questions to see whether we are able to absorb all of this knowledge, and if not, in what particular way we should think about or read the questions. The general outer electronic configuration, outer, okay, of the D block elements is going to be the valence shell electrons. The valence electrons, where should they go? Do let me know. So n minus 2 d ns, n minus 1 ns, n d ns, n plus 1 d ns. It's easy, right? It's always n minus 1 d from 1 till 10, ns 1 and 2. Correct? The correct answer to this question is going to be B. Amazing, everybody. And now let's talk about, and by the way, if you think these questions are easy, then my dear students, such type of questions would be there in JEE and NEET examination. Yes, periodic table is the most easiest chapter when it comes to class 11th. So do remember that. And now over here, fourth shell of an atom contains 4s, 4p, 4d and 4f. Which subshell are not filled in any fourth period element? Fourth period element we are talking about. So in the fourth period, whenever we talk about elements, so anyhow 4s and 4p are going to be filled. Okay, 4s like potassium, calcium, these are going to be having 4s1 and 4s2. And later when we talk about even a post transition elements like group 13 till group 18, 4p will start getting filled. Which one of them is not going to get filled? And the correct answer to this question is going to be 4d and 4f, because while we are talking about 4s and later 3d is going to get filled, and there is nothing as 2f. So do remember that. So 4d and 4f are not going to get filled whenever we are talking about the fourth period. Now I'll ask you one more thing. Then when we are talking about the fifth period, whenever we're talking about the fifth period, I'm asking you something. The question is not complete. Is 4f filled? Is 4f filled? Let me know. The correct answer to this question? No. 4f starts getting filled in period number 6. Do remember that. After cesium and barium, right? We see the group 3, and then after lanthanum, then you will see 4f electrons, 4f getting electrons. Okay, do remember that. Yes. So now let's move ahead. 4d4 5s1 configuration belongs to which group? Or even 3d4 4s1 belongs to which group? What you really have to do, add the number of electrons available in 5s, I mean s, and then in the case of 4d, how many? What is going to be the scenario? Do you think something is wrong over here? No. The correct answer to this question is absolutely going to be second. And why is that? Because, एक second, something is wrong. Oh ho! Give me a second, boys and girls. Something is wrong with this question. Give me a second. This cannot happen. Chalo. Okay. So over here, whenever we're talking about 4D, it should be 5s2. Correct? And whenever we talk about 5s2 and 4D, it should be 6. So ultimately, even this is going to be wrong. Sixth is going to be the correct answer. Sixth group is going to be the correct answer. Okay? Leave this question. And now let's talk about the next one. In the following electronic configuration, ns2, n-1d, 0 to 1, n-2, f1 to 14. Okay, we're talking about which elements you should know. If the value of n-1 is 6, the configuration will be of n value n-1 being 6. This one will become 7. n-2 will become 5. So ultimately we're talking about period number 7. And the case of period number 7, when 4f, when f electron starts getting filled, we're not talking about lanthanides. We are talking about actinides. Do remember that. Okay. Do we have period number 8? Do we have period number 8? Yes or no? Let me know. Come on. Do we have period number 8? No. Amazing. Okay, na? So actinides are belonging to period number 7, lanthanides to period number 6. Okay. Do remember that. What happened, genius Yuva? You're laughing? What? Let me know. Acha. So now we are going to talk about how do we really measure. What technique, what calculations, what assumptions do we make whenever we are calculating the atomic radius? Do remember that. Guys, let me know one thing. Let's talk about lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Guys, how many protons do we have here in the case of lithium? It's 3. How many do we have in the case of fluorine? It's 9. Right? Which of these atoms are going to be big ones? Which is big, lithium or fluorine? Let's compare. So wherever the number of protons in the same period, these are all in the same period, correct? Whenever the number of protons are less, the size is going to be big, because the number of protons are less to pull the number of electrons. But when we talk about the number of protons being more, then what's going to happen? Now 9 protons are all around, wherever the electrons are going to be, they are, these 9 protons are going to pull these electrons. So here I am trying to show you the representation. Try to understand. Now from lithium to fluorine, or across a period, size decreases. Why? Because the Z value increases. Do remember these. But now guys, also remember one thing. What is the size of neon? Is it going to be bigger or smaller? Hypothetically speaking, it should be smaller, because the number of protons are increasing, correct? And in reality as well, the size of the neon is already going to be smaller. But we still, what do we write on paper? The size of the neon is bigger than size of the fluorine. Because why? Because even we know what's the reality, what reality would be, but we are not able to prove it. We are not able to prove it. and whenever we cannot prove it, we cannot put it as a fact. Okay, we can keep it to ourselves but not as a fact. So for now, the size of the neon is bigger than the size of the fluorine. You know why? Because I'll tell you something. Because of the van der Waals radius technique and the covalent radii technique. So I would tell you something. Whenever we have a nucleus and we have an atom, the electrons which are the outermost ones, the electrons present in the valence shell or the outermost shell, it's a cloud. It's a cloud. So we exactly do not know from here till here is what we should take, or from here till here is what we should count. We do not clearly know. So then what do? Then we take the help of two atoms. So in the metallic radii, when we talk about the metals, how these metallic atoms are something like this. Okay. So what do? We take the distance between two nuclei, internuclear distance. Okay. And then we break it, then we divide it by 2. This distance is what we keep it on our piece of paper as the size of the atom. This is metallic radius. In the case of metals, the one atom and the second atom is very much closer but not overlapping. And now when we talk about the covalent radius, the atoms are overlapping each other because they are sharing electrons. And now guys, pay attention. Something like for O2, oxygen, double bond oxygen. Okay, this is the nucleus, this is the nucleus. You take the internuclear distance, could be any value, and this value anyhow is going to be in Armstrong, 10 raised power minus 10. But when you take a mean, I'm going to remove it again and make it again something like this. Yes. Now eventually you should know that the atomic radius should be from here till here, correct? But now what we are counting it as from here till here. Whenever we use the covalent radii technique for any covalent molecule, for same covalent molecule, the answer comes out to be always precise. And if we cannot be accurate in science, guys, for future scientists and researchers, I'm telling you, if you cannot be accurate, at least you have to be precise with a logical answer. And this is the logical answer, that as these two atoms are overlapping, but whenever we try to calculate their internuclear distance and divide it by 2, we always get the same answer. So another person will ask you, what about the actual radius? You can say, I do not have the technique. If you have, you can tell me the answer. What he will say, sorry, whatever you're giving me, I'll take it as a fact. So that's the reason the size, now over here the atomic radius is going to be from here till here. And also you should remember that from an actual radius, from the actual size of the atom, the covalent radius technique will always give you the size which is going to be smaller. And when we talk about the van der Waals radius, so which technique will you use for F and F? I mean for fluorine? For fluorine atom radius, if you have to evaluate, if you have to judge, if you have to measure, you will use the covalent radius technique. But when we are going to talk about neon, so neon does not make compounds. So what is going to happen in the case of neon? One neon atom, another neon atom. These are gases, and gases have too much of interatomic or intermolecular distance. Here it's atom, so interatomic distance is more. Do you see a nucleus? Yes. Take the internuclear distance divided by 2. Whatever radius that we are calculating, is it actually bigger than what the real atom is? So now the actual radius should be from here till here, but now what we are calculating is from here till here. some extra space as well, and that's the only reason if you would see any data, the neon size is going to be higher than fluorines. So do remember this. Is this clear to each and everybody? So guys, now pay attention. Whenever we are going to talk about the radius of an atom, if we are talking about the same atom and trying to calculate their radius with 3 different techniques, then covalent radius measurement is going to be the least one, the smallest one, then the metallic, and then the van der Waals. Do remember this. Okay? Yes or no? Clear? Amazing. And this is how, but now let's talk about the radius of the anions and the cations. So now guys, pay attention. Metallic radius is what I have told you, so don't worry about it. Whenever we talk about the ionic radius, you should remember what we look for is the internuclear distance between the anion and the cation. This distance is going to be because of the anion and the cation. And then if you can do it by 2, that is not going to give you a good answer. But you should remember, whenever we are talking about a neutral atom having this much size, and whenever we provide extra electron to a neutral atom, whenever extra electron goes over there, in electron and electron repulsion happens. Okay, let's talk about it. Let's say I have fluorine. How many valence electrons does fluorine has? 7. 1, 2, 3, 4, 5, 6, 7. Now if I try to feed fluorine with an extra electron, will there be a lot of repulsions? That repulsion is known as inter-electronic repulsion. Inter-electronic repulsion. And then in this scenario, you should remember, electrons repel, and as they repel, the size becomes bigger. So now in order to accommodate this extra electron over here, initially this, the size was this much, right? And now let's see, I'm talking about 8 electrons. Right. Do you see? The size of the atom will increase, correct? So do remember that. So the anionic radius is always greater than neutral atoms radius. Okay, radius of the neutral atom. Now we'll talk about the cationic radius as well. Pay attention. Whenever we talk about, let's say, sodium has shell number 1, shell number 2, shell number 3. There is the outermost electron. What if I remove this electron? Ultimately, we do not have to talk about the shell number 1 or shell number 3. Correct? Did the size of the atom which became a cation, did it decrease? Yes. So size of the cation always becomes smaller than the neutral atom's radius. Okay. Do write this down in your notebooks. Effective nuclear charge increases, number of shell decreases, size decreases. Effective nuclear charge increases. So whenever we remove, see, ultimately, yes. See, whenever we talk about the effective nuclear charge, and you are talking about it increases, you're talking about number of shell decreases. Yes, you're talking about in the case of cation. Okay. Is this really clear to each and everybody? Come on, let me know. Yes or no? Sir, when session over? Session is going to get over. Yeah, come on. Whenever I take a session for 1 hour, you guys say, sir, it's just 1 hour. Whenever I say take a session for 1.5 hours, you guys say, sir, it's too much. Is it? No. Anyhow, don't worry. Session is going to get over just now. Okay. So just, the van der Waals radius is always greater than the metallic radius, is always greater than now the anionic, covalent and cationic. Do remember this trend. Okay. So van der Waals radius are always damn bigger, all because of that extra space, interatomic space. Okay. And what all factors decide the size? Size of the atom depends upon effective nuclear charge. Effective nuclear charge depends upon the number of protons and the number of electrons. So over here, do remember, whenever the effective nuclear charge increases, which can only happen when the number of electrons decrease or the number of protons increase, then size decreases. Inversely proportional, when the number of shells increases, size increases down the group. So this one I'm going to write across the period. Okay, this one down the group. Do remember that. Okay, the number of inner shell electrons increases. The number of inner shell electrons increases. Electronic repulsions in the case of anions, and the size of the is inversely proportional to bond order. We'll talk about the bond order thing in the next chapter. We'll talk about this in next chapter. Okay, but don't worry, the reason I'm showing it to you right now is because I am going to discuss this. Okay, is this clear? Teach as long as you can. We will be there till the last second. Amazing, yeah. Genius you are. You're good. Chalo, amazing. And over here, I have to summarize each and everything, because anyhow, I had been telling you, cross the period down the group, so don't worry about the size and all. And now, ultimately, if you have any doubts, because anyhow it's too late, and I am going to be, always available on Telegram or in my group. But if you really want to ask any doubt, then ultimately use the Ask a Doubt feature on Unacademy, where you can always, ask unlimited doubts at any time, and you will receive high quality video solution. High quality video solution in English as well as in Hindi. Don't worry about it. Okay. And apart from this, you should just remember that you can take a screenshot, clip it, crop it, and then send it. But you should remember that ultimately these images should be clear, one doubt at a time. All the options should be available. You just have to give a doubt in such a way that whosoever is going to receive your doubt, he or she can really understand it. Okay, so do remember that here. And then yes, and ultimately do not post multiple doubts, because ultimately then if your cropping is not really clear, if you actually put 5 doubts in one photograph, then which one should be given more priority, we do not know. Okay, so do remember that. And this is where we are absolutely at the end of this class. Do like this video. Come on, boys and girls, what are you guys really doing? And share it with your friends. If you have a friend to whom you want to make him more intelligent, if you want to increase their IQ, with respect to the subject, do share it with them, and subscribe to the channel. And ultimately we are going to meet in the next class. Okay, yes, and you just have to follow me on Unacademy, and every day at 9 p.m. I am going to be bringing up these sessions for you. Okay, so let's meet again. All the best, take care, stay safe. It's 10:40 right now, 10:40 p.m. and from now your classes are going to be lengthier. Always remember, I am going to be bringing up classes which will take 1.5 hours minimum, 1.5 on an average, so do remember that. Amazing. Chalo, bye bye, tata, love you all, take care. Mouse not working. Hello bhai, bye bye.